So as we start the second half of Chapter 2, page 1 of your packet has a bunch of basic graphs here. So what I want you to do is to study these very carefully and see how these points are made. So the square root function, that's its name. Make sure you study the names. The square root of x is just this little arc right here. Sometimes people call it a shooting star. The square root of 0 is 0. The square root of 1 is a 1. The next point you notice here is at 4. Radical 4 is a 2. Square root function. The cubed root function looks like this. Notice there's also some values over here on the left-hand side because you can plug negatives into a cubed root. Cubed root of 0 is 0. Cubed root of 1 is a 1. Cubed root of negative 1 is negative 1. The next value that you're going to find is the cubed root of 8, which is a 2. Okay, cubed root function. Absolute value graph looks like a V. The absolute value of any number, positive or negative, becomes positive. Notice how the points fill up all the graph paper, arrows off the edge. A constant is just a horizontal line. This would be like a hoy, y equals numbers, whatever number it is, just a constant function. The identity function is x. So when you put in 1, you get 1. Put in 2, you get 2. Put in negative 2, you get negative 2. That's the line y equals x. It's called the identity. Whatever number you put in is the exact number you get out. The square function, that's its name. The shape is parabola, but the name is square function. So it's the shape of a parabola. 2 squared is 4. There's the curve right there. Okay, we're going to be studying graphs this entire chapter. The cube function, x cubed, so 0 cubed is 0. A lot of these pass right through the origin. 1 cubed is 1, 2 cubed is 8 off the graph paper. The reciprocal function right here does not touch 0. You cannot put 0 in the denominator, so that's going to be an asymptote. He also has an asymptote right along the x-axis. Okay, so he does not touch either of these axes, unless, of course, it's shifted a little bit. But the basic one, 1 divided by 1 is 1. When you put in 2, you get a half. So as you go farther here, they get smaller, smaller fractions. If you put 1/2 in, 1 over 1/2 reciprocals and gets a 2. Okay, so the reciprocal function touches the points -1, -1, and 1, 1. Okay, so when you're drawing, these don't just draw, ugly things. Make sure you touch the right points. The greatest integer function is you take any value, like 0.5, and you make it be just the integer. So 0.1, 0.2, 0.9 is all on 0. But when you get to 1, it jumps up. Notice how 1's an empty bubble, 1's a full bubble. This is the greatest integer function. We're not going to deal with it too much this chapter, but it's really nice to know, and you will see that in your future. Okay, so what are we doing with these graphs? Studying them, of course. Okay, but the first thing that we're going to talk about here is rigid transformations. And by rigid, that means stiff. Okay, so the graph itself is not being stretched out in any way. Okay, the graph itself is going to be the exact shape. We're just going to move it left and right. So the first thing we're going to study here is horizontal translation. And that means to shift left or right. Okay, translation actually means to slide. If you translate in language, you slide from English into another language. Okay, and so f of x can be translated c units to the left. So when you're going to the left, it's going to be f of, and inside parentheses is x plus c. Well, that's weird. I thought it said left. Yeah, left, you get a plus. Similarly, c units to the right is going to be f of x minus c. Now, there's a couple things I want you to notice here. Okay, very important. You see these c's? These c's are inside the function. Inside the function. You can take a look at some examples here. Do you see how the plus 3 is inside the radical? Do you see how the 1 is inside getting cubed? Inside the absolute value? Okay, inside the function means that it's shifting left and right. And horizontal translation is a little weird. Okay, sometimes people call these the X-files. X-files because it's not exactly what you would expect. It's kind of the opposite. Okay, we're going to practice graphing some of these. So we're going to take x plus 2, and I'm going to ask you, is that 2 inside? And it's yes, it's inside. So plus 2 means 2 units to the left. Okay, now the first thing I need to know is what does x squared even look like? So for today's lesson, you might have to refer back to page 1 until you study really hard. And x squared, okay, is the shape of a parabola. And it starts at the origin. Except this parabola has to go 2 to the left. So 2 tick marks to the left, and this is where we're going to start the parabola. Now for today, we're just going to draw nice little sketches of the grass. Tomorrow, we're going to get graph paper and we're going to do point by point. Today, your job is to get familiar with the shifting and the graphs themselves. All right, part B. Is that 4 inside? Is it inside the absolute value? And the answer is yes. So that means 4 units to the right. I was expecting left, but that means to the right. Okay, and what does absolute value graph look like? The absolute value graph right here looks like a V starting at the origin. Except this one needs to go 4 to the right. 1, 2, 3, 4, and that's where we're going to put our absolute value graph. That's where the V is going to go. Okay, question C. Is that 1 inside? Is it getting cubed? And the answer is yes. So that's 1 to the, remember it's a weirdo, it's the opposite of what you think, 1 to the right. 1 unit to the right. And the second thing I need to know is what does x cubed look like? What does a cubic look like? The cubic function looks like this. Curvy, curvy S right through the origin. Except this one is starting right there. There's the starting point. So it's going to be curvy, curvy, cubic. Don't forget your arrows, just like that. Okay, this last one. Is that 3 inside? Is it inside the function? Then plus 3 means you go to the left. 3 to the left. And what does the square root function look like? Okay, square root function starts at the origin. Some people say it looks like a shooting star. Okay, so we're going to go 3 to the left. 1, 2, 3. Shooting star like that. Okay, for today, I want arrows, I want the starting point, and just rough sketches. We're going to do point by point by point starting tomorrow, very precisely. Okay, the next thing we're going to look at here, another rigid transformation, is if it's vertical. Vertical translation. So this means to shift, okay, to shift the graph, not stretch it out, just shift the graph up or down. Okay, and this one's not weird. This does exactly what you would expect. So if you're going to translate it up, then it's going to be f of x. Stop your function. Stop the radical. Stop your absolute value. Stop everything. And then outside, you're going to put plus d. Up d gets a plus. How do you go down? F of x, stop your function, and minus d. Okay, and what I want you to notice here with this notation is that these d's are outside the function. Okay, very important that you know what the equation is telling you to do. Is that 3 in the radical? No, it's radical x, then plus 3. Is that 4 getting squared? That's x squared, and then that's a 4 afterwards. Do you see how it's 2 after absolute value with the 1? So these are all going to be shifting up or down. So that 3, it's going to be 3. Is it up or is it down? Plus d plus 3 goes up. It's exactly what you'd expect. So let's go take a look at the square root function again. Remember how he looks like that shooting star? Starting at the origin. Oh, except he's going to start 3 units up. 1, 2, 3. There it is. Up 3 units. That 4 is outside. Okay, so that means shift 4 units down. 4 units down. The squared function looks like a parabola. But we're going to start 1, 2, 3, 4 units down. Put the parabola right there. Okay, you're going to have to know what those graphs look like without looking back to page 1. 1 over x, we haven't done one of these yet. 1 over x is the reciprocal function. He's got asymptotes on the x-axis and the y-axis. Except there's a 2 here, and that's 2 units up. So if we take a look at these asymptotes, the asymptote on the y-axis is still going to be on the y-axis. But the x-axis asymptote, that one's going to get shifted up too. So the y-axis, if I shift that up, it stays on the y-axis. There are the asymptotes. Now there used to be a point right there, 1, 1. 1 point away from the asymptotes. It's not there anymore. Here's your asymptotes, and you're going to go 1, 1. I believe the point is right there. I believe the point is 1, 3. Is that true? 1 divided by 1 plus 2 is going to make a 3? Absolutely. Now we're not going to get in the habit of plugging numbers in. We're going to get used to transformations. The other point is going to be right here. 1 unit right there. And then we're going to approach this asymptote, approach that asymptote. So I want to see these starting points. Just like the starting point of the parabola, you have to know where the reciprocal function starts, and it's 1 unit off. All right, this last one right here, since that's outside, that's shifting 1 unit down. Absolute value graph looks like a V, but we're going to shift 1 unit down, and there is the V. Okay, so shifting up, down, left, right, you have to know which one they're saying by where the number is in the equation. Okay, some more rigid transformations are reflections. Okay, reflection means to flip over a line. To flip over a line. Remember how the graphs were symmetric? The inverses of the line y equals x. We're going to reflect over the axes. Okay, so the first one here is to flip over the x-axis. And when you do that, f of x needs a negative out in front of it. Okay, so let's just put a little note here. That negative is outside in front of the function. Outside in front of the function. So spend some time memorizing these rules today. Do you see how that x is in front? That x is out in front. It's not getting squared, it's in front. See how this negative is in front of the radical, not inside of it? See how this negative is in front? Okay, this negative right here is also in front. So what does that negative mean? What transformation does that say? That says reflect over the x-axis. So what helps people sometimes is to see a regular parabola. What does x squared look like? Well, the regular one looks like this. Okay, but I have to reflect him over the x-axis. So this parabola needs to go down there. That parabola needs to go down there. So the parabola is now going to be opening down. Okay, I did that dotted one just so you could see the original. You don't have to do dotted. If you do draw that, make sure it's not solid because the actual graph is right here with arrows, the solid one. Okay, what does that negative mean? It means reflect over the x-axis. So what does the regular square root look like? Let's just remind everybody. The regular square root, some people say it looks like a shooting star. So if that's the regular one, what does the reflected one look like? When it's got to go over the x-axis, it's going to be down here in quadrant. What quadrant is that? Oh, let's just remind everyone of the quadrants so we know how to talk. This was quadrant 1. This one is 2. This one is 3. And it's in quadrant 4. Okay. Absolute value graph. But what's the transformation? You have to say it's reflected over the x-axis. So the regular absolute value graph looks like this. Looks like a V opening up. It's still going to start at the origin, but the V is going to be opening down. Okay, and the last one here has a negative in front, so make sure you say reflect over x-axis. Okay, that's describe the transformation. That's going to be part of the work that we do this chapter. And let's see, 1 over x. 1 over x, where'd that reciprocal guy go? Here he is again. Here he is. We have to reflect him over the x-axis. So I used to have this branch up here in quadrant 1. I used to have a branch like this. I guess I could draw it for people at the point 1, 1. But when I reflect over the x-axis, it's going to go down here. So he is going to have one of the branches in quadrant 4. Okay, now what about the left-hand side of the graph? The left-hand side used to have a point right here, and he was in quadrant 3, but when you reflect over x-axis, it's going to go up here, so his branch is going to be in quadrant 2. You certainly don't have to do the dotted ones. I'm just trying to make sure that I explain this clearly for everyone. Okay, you just need to draw the reflected over x-axis one. Okay, what else do we have? Reflection over the y-axis. Okay, so here's what the equation is going to look like. The negative can't go out in front. It's got to be in a different place. So it's f of negative x. Y-axis, there it is. So where's the negative going to be found? Inside the function. Inside the function. Take a look at these examples. Do you see how it's in the radical? Do you see how it's inside the absolute value? Inside getting squared. So parentheses are super important. This one was outside, not getting the squared, and this one's inside, getting squared. So let's just ask you, what does this negative mean? Since it's inside, it means reflection, and then you have to say which axis. This would be the y-axis. The y-axis. So what does a regular square root look like? The regular shooting star starts at the origin, and when I reflect over the y-axis, it's going to flip to the left. It's going to be right here in quadrant 2. Okay. Example B, what does this negative mean? It means reflect over the y-axis. So what does a regular absolute value graph look like? It looks like a V. If I reflect him over the y-axis, anybody on the right goes to the left. The left goes to the right, and the graph that you get would be identical. Some people say, well, why is that? Why would it be identical? Because the absolute value of a negative turns positive, so the equation would take care of that negative sign. Right here, this is a reflection over the y-axis. So the regular parabola looks like this, a regular parabola. When I reflect over the y-axis, the right goes to the left, the parabola is going to be in the same spot. Really? The same graph? What's a negative x times a negative x? Oh, positive x squared. So he does look like regular x squared. Not all of them do. The first one didn't. And neither does this one. This is a reflection over which axis? If it's inside, the y-axis. A regular cubic looks like this, but I have to reflect over the y-axis. So this one is going to go over here. It's still going to pass through the origin. And this branch is going to go into quadrant 4. There's a negative over the y-axis, a reflection when it's inside. Okay, now what we're going to do is practice writing equations. So what I want you to do is to look at these graphs, and I want you to study them and then write down what you notice. Okay, first of all, do you know what equation this parabola is? This is an x squared. But I notice it's down here. Okay, what does that mean when it's down here? It's been reflected. It's been reflected over the x-axis. Okay, so how do we write the equation? First of all, make sure you write f of x. Okay, an equation has to have an equal sign. So f of x equals, I know my equation is going to be x squared. But now I got to make sure that I get this information and look back in your notes and figure out how you say reflection over x-axis. Reflection over x-axis, the negative has to go outside. It's going to be just like this. So it's going to be negative x squared. Good, okay. The next one, let's take a look at this. Here's the starting point. That always kind of helps me. I noticed that this equation is a cubic, so this is an x cubed function. But they usually start to the origin. This one's starting 3 down. 3 down. So I need you to go back in your notes and look to see how you write something 3 units down. Did you find it? Does it go inside or outside? It goes outside. Okay, so let's start. Hey, I said start. Let's start with f of x, good, equals x cubed. And then afterwards, we'll put minus 3. Cover it up with your fingers. Is that x cubed? Yes. And then afterwards, minus 3. Okay. This next one right here kind of looks like a shooting star. This is x squared. The regular squared function is over here, but this one's shooting to the left. So what happened? It got reflected over the y-axis. Reflected over the y-axis. Okay, so let's start. F of x equals reflected over y-axis. Where are you going to put that negative? That's right, inside. So draw a square root. Put the negative inside the radical. And the last one here is a v. This is an absolute value graph, right? They usually start at the origin, but I noticed this one is starting 2 to the left. This one got shifted 2 to the left. So make sure you start f of x equals absolute value of an x. Where are we going to put that 2 if it's going to the left? It's definitely going to be inside. So it's going to be x. Oh, but wait a minute. Remember left-right is a weirdo? Remember left-right, if we want to go 2 to the left, we have to say plus. So we're going to say absolute value of x plus 2, close up the bars. Okay, the more you practice with these basics, the better you're going to get. Okay. Circle all the equations that indicate a horizontal shift. Okay, so this is just practicing noticing equations. Horizontal, left or right, is going to be inside. So let's talk about these, and you shout out yes or no, and then your mom will know you're doing your homework. Okay, is A left or right? Is that 4 inside? Yes. B. No. C. Yes, that's inside. That's 2 to the right. D. Oh, that 11 is outside, and that 5 is not plus or minus. No, that's not a shift. Here's the squared. Here's the squared. The 10's after. That is not left or right. F. Yes. Okay, so 3 of them were left or right. Circle all the equations that indicate a shift up or down. Okay, vertical shift up or down. This is going to be after, outside the function. Okay, A. No, that's inside. B. B. Yes, that's up 5. C. Nope. Is D up or down? Yes, it's down 11. Yes, E. Here's x squared. And then that's plus 10 after. Yes, that's up 10. F? No, sorry, Bob. Okay, which ones are reflections over the x-axis? Where is the negative sign for x-axis? Outside. Outside in front of the function. Is A over the x-axis? Yes. B? No, that's inside getting cubed. C? No, that's inside. D? Yes, we got one. E? Here's squared. Is that in front? Yes, that's not getting squared. Oh my goodness, what's going on here? F? Here is the quantity cubed. Is that negative outside? Yes, outside. And finally, can you find equations that are reflections over the y-axis? Y-axis is going to be inside. So let's see. Is A inside? No. B? Yes. C? Yes, that's inside. D? No, siree, Bob. E? Here's the squared. It's not inside. Nope, that's in front. F, this is that weird one. Here's quantity cubed. Is that negative inside getting cubed? And the answer is yes. This equation here is interesting because this means reflect him over the x-axis. And this one means reflect him over the y-axis. Yes, you could have double reflections, and I can't wait to teach you all that stuff tomorrow. Bye, guys.